Alright, here we go. I'm going to do the key for today's set of problems. So here we go. First one, I'm going to solve this for y. I know it's a little difficult, but I have faith in you. So I'm going to add 2x to both sides. Those will cancel away. Bring down this 2y. Do not add these two. Bring down the 2x first, bring down the 4. And then my next step, the opposite of multiplying by 2, dividing everything by 2. And what that does, gives you the equation y equals x right here, or 1x, or 1 over 1 plus 2. That is the equation's equation. Alright, the graph. This one has a y-intercept of 1. It has a slope of over 1, up 1, or up 1, over 1. That put into rise over run, if you remember. Going over 1, up 1. That number is my slope. When I write my equation in slope-intercept form, that 1 over 1 goes right here. That y-intercept goes right here. So that ends up giving me 1 over 1x plus that y-intercept, which is 1 right there. Alright, now I can answer my questions. This one's got a y-intercept of 2, has a slope of 1 over 1. This one has a slope of 1, a y-intercept of 1. This says, the equation and the graph have the same rate of change, same number in front of x. That one is true. The equation has a greater rate of change. So this one, if that was a bigger number than that, that would have been true, but they're equal, so that's false. The graph has a greater rate of change than the equation, again, false. The rates of change cannot be compared. Always cross that one off on all these. Alright, problem number 1. Problem 2. Again, solving this for y. Adding 4x. Those will cancel away. Bring down this 5y. 4x and 10, do not add those. That gives you 4x plus 10. Divide everything by 5 right there. I know that's tricky. Those go away and gives me y equals 4/5 x. I'm going to keep that plus 2. The other problem, the graph, looks like it's got a y-intercept of 2. This one also has a slope of a run of 1, a rise of 1, so it's got a slope of 1 over 1, which is 1. So this one's equation, when I replace this m right here and this b with 1 and 2 right here and 1 right here, gives me 1x plus 2. Alright, now I can compare them. 1 over 1, this is 1. This is just below 1. If it was 5 over 5, that would be 1. So you can see a tiny bit below 1. A little bit smaller than this one right here. So the equation and the graph have the same number in front of x, same rate of change. That is false. The equation has a greater rate of change than the graph. That's a little bit less than this one, so that is false. This equation's rate of change is smaller than the graph's rate of change. False. The graph has a greater rate of change. Yes, this is a 1. That is slightly more than 4/5. Remember, 1 is really 5/5. So again, if you're trying to compare barely above, that one is true. And then always cross off that one. Alright, one more in this set, and then I'd like you to do a couple on your own. This one right here, this is a negative 1x. So to solve this one for y, I'm going to add 1x to both sides. Those will cancel away. Bring down this 2y. Do not add 1x and 6. Write it just like this. Divide everything by 2. And that gives me y equals 1/2 x plus, and then this turns into a 3 right there. This right here has a y-intercept of 2. It's got a slope of over 1 up 2. So if I made that in my slope, that would be 2 over 1. And if I put those together with slope-intercept form with the m number here, 2, the b number 2 going right there, that gives me 2x plus 2, which I could always write 2 over 1, of course. Now I could compare. The equation and graph have the same rate of change. That is false. The equation has a greater rate of change. This is a half. This is 2. That is definitely false. The graph has a greater rate of change. Yes, 2 is more than a half. 2 of something is more than a half. So that is true. And then never choose this one right here. Alright, the next two I would like to see you do. Solve those for y. Get your rise and run, get your equations, and then do those questions. Alright, next type is this table one. Here we go. So for this one, they want you to find the equations again, and then they want you to answer these questions. Which one has the bigger y-intercept number? And then which one has a greater rate of change or slope or m or number in front of x? That's what they're asking. So to get the equation from these, here we go. You need always the y-intercept and the slope. To get the y-intercept from a table, you look at the 0 term right here. When x is 0, the y number, that's the y-intercept. For a graph, wherever it's touching the y-axis, that is the y-intercept number that goes in there. So again, table, look for the 0 term. Graph, look where it's touching the y-axis. That number is your y-intercept. Then you need slope. For a table, it's the rate of change from the y numbers, and you can see this is going down by 3. That's a little trickier, going down by 3. So this one has a rate of change of m of -3. That's my slope number. That's going to go right here for slope. For this graph, it has a slope of over 2 for my run. This should look familiar. Down 3 for my rise. They're hoping you write that slope as 2 over -3, but this slope is -3 over 2. Slope is always rise over run. And even though that number is on top, that's your run. This number is your rise. That goes on top. So here we go. My equations. This one has a y-intercept of 2 and a slope or rate of change here. The slope is always change in the y over the change in the x. So this is really just going up by 1s right here, so I'm not really worried about that. But again, this is -3. The y-intercept number is 2. So that first equation is -3x plus 2. That table's y-intercept. That table's rate of change. The equation, this one's rate of change, this one's slope is -3 over 2 x. And then its y-intercept number right here is 3, 4, 5, 6. Alright, now it says, which function greater y-intercept? This one's got a 6, this one's got a 2. The graph. And then maybe show your work when you're doing this on the test by typing in both so I could see clearly that this one, the graph one's got a bigger y-intercept. Maybe you could even, when you're typing those in, label those. And then the next problem, which one has a greater slope? And you can see this is a little trickier one. This one is -3 over 1. This is -3 over 2. Be real careful. This is tricky. This one is actually going down steeper than this one. by a slightest little bit. Every time you go over just one box, you're going down 3, but this one you have to go over 2 before you go down 3. So that makes this a slightly bigger rate of change. That's really tricky, I know, but this one is a quicker rate of change going down than this barely slightly. Memorize this one. So which one has a greater rate of or greater slope? You would say the table. And then again, if you could type those graphs in or write those equations in, or tell me the slope for each one, then that would be enough to show me. But again, which one has a greater slope? The table. It's going down faster. Which one has a greater y-intercept? The graph. It has a bigger number. All right, next problem. Do a couple. Have you do a couple on your own. Here we go. This one. This table, y-intercept of 2. This one is going down by 5, going down by 5, going down by 5. So that's my slope. So this one has y equals negative 5x plus that 2 number right there. This one has a y-intercept of 3, 4, 5, 6, 7, and it's got a slope of right 2, down 1, 2, 3, 4, 5, down 5, 1, 2, 3, 4, 5. So that one's equation is, with the correct numbers in the right place, negative 5 over 2x plus 7. Now I can compare. Greater y-intercept, the graph. And then again, tell me on the equation, tell me why. It's got a 7. Which one has a greater slope? And again, this is tricky, but that negative 5 over 1 is going down slightly faster than this one. Going over just one box and then down 5 is going down quicker than going over 2 and down 5. This is steeper, barely steeper. So this one has a greater rate of change. So you would say the table again on this one. All right, one more. This one, y-intercept of 3, going down by 3. That's my y-intercept number. So that would be negative 3x plus 3 for the table. My graph, y-intercept of 2, a slope of right 1, down 3. So again, if I write that slope in the right way, negative 3 over 1. So this one has negative 3x plus 2 for the graph. All right, which one has a greater y-intercept? The table for this one. Which one has a greater slope? And you could say neither. These two are equal. Not even equivalent. Equal. Exactly. Negative 3, equal. All right. I'm going to have you do a couple on your own. I'll come by and help you. All right, third type is this one right here, which has you, again, write the equation from this and then figure out and answer these questions from it. So for this table, you don't have the zero term. You need to go back a step and find that. So it's a little trickier, but here we go. For this one, it looks like these are going up by 3. So not negative for these ones. They're going up by 3. So that means if I do the opposite pattern to find that zero term, take 13 minus 3 going this way. That gives me 10. That is the y-intercept term. That is how much you're paying 0 after not even running anything at all. That's what they want you to understand. So if you write this equation, y equals the 3, the number that is going up each time, plus the 10. What that's telling you that this is the price you're paying per hour, $3 per hour. That's what that number is right there. You're paying $3 per hour. This number right here, 10, is the number that you're paying after renting it for 0 hours, which means how much you're paying right away, even before you start renting, or the initial base cost, what this is calling, which means, again, the cost you're paying before you even start renting a canoe. So again, the rate of change comes from here, how much you're paying per hour. It's never this number. That's not $13 in 1 hour. Nope, because the zero term is 10. That means, again, this is your rate of change, your slope. This is your zero term, your starting point, or how much you're starting to pay, or your base cost. So here we go. Answer the questions. The price per hour is $13. Don't fall for that one. Nope, it's not $13 for 1 hour renting. Nope, don't do that. The base charge is 13. Nope, the base charge is the y-intercept, 10. That's not true. The price per hour, $3 per hour. Yep, that matches. The base charge, 10. The y, yep. All right, next problem. Again, find your slope or your rate of change or your common difference. This is 2. To find the zero term, go back a step, subtract 2. 7 minus 2 gives me 5. Put those together. Y equals this rate of change number. That's your slope. That's your number that goes in front of X. That's your $2 per hour. That's your charge per hour. How many hours you plug in here, and by $2 per hour, by number of hours, gives you how much you're paying right there. Plus the y-intercept number, which again is the base charge. How much you're paying after renting a canoe for 0 hours. Even before you sit in a canoe, you have to spend $5 to even get in there. So the base charge, maybe a deposit or a fee to get into the place where you're going. I'm not sure. But here we go. Price per hour, $2. Yes, that is true. That matches this. Base charge, 7. Nope, they're trying to bait you into thinking that's the base charge. Nope, mine's 5. The price per hour rental, nope. Again, don't fall for that trap. They're hoping that you're going to pick this one. The one, people. And then this one, base charge 5. Yes, that matches my y-intercept number. All right, one more of these, and then I'll have you do a couple on your own. So here we go. This one going up by 4. Using that pattern, subtracting by 4, going this way, gives me 6. That's my y-intercept number. My 4, that's my slope number. Again, my common difference, my slope number, same thing. My rate of change, slope, same. My y-intercept number is 6. This equation is y equals that number in front of x plus the zero term in the table. That's my base charge right there, how much I'm paying after renting it for no hours. That's my price per hour. So here we go. Price per hour of $4, yes. Base charge 6, yes, right away. And then the 2 ones they're trying to bait you. 10 and 1, nope. Nope, don't pick that one. All right, I'm going to have you do the next 2 on your own. I will come around and help you. Alright, the second to the last problem, this one, has you find the rate of change and compare them. So bus number 1, 50 miles per hour. So this is rate of change. 50 miles for every 1 hour it's driving down the road. That's its rate of change. This bus number 2, from the graph, again, you got to look and see. So you're going to compare this number right here for its 1 hour. You want to find its base unit rate for every 1 hour. So if I look, this is 50 right here. This is 100. So I could estimate maybe about 70 or so that this graph is telling me. 70 miles for every 1 hour. So bus number 2, about 70 miles for every 1 hour. Now you can answer the question. Which bus traveling at a higher rate of speed? And for this one, it's bus number 2. That is the graph. And then again, to explain, I need you to type in there that bus number 1 has 50 miles in 1 hour. And then bus number 2 has a slope or a common difference or a D of 70 miles. So going further in 1 hour. This graph would be steeper. This graph 50 would be less steep for 50. Steeper, greater rate of change. So this one is bus 2. And in your explanation, show me that. Alright, couple more. This one right here, bus 1, 45 miles for every 1 hour. That's bus number 1's speed. Bus 2, if I look at it, this is right on the nose, 50 miles for every 1 hour. And you can see bus number 2 again, the graph, has a greater rate of speed. How do you know again? Again, you'd have to type in and show me. Bus number 1 is 45 miles for every 1 hour. Bus 2 is 50 miles for every 1 hour. You got to show me. All right, one more of these. This one, bus 1, 55 miles for every 1 hour. Bus 2, you can see for this one, it's just below 50. So maybe about 48 or so, maybe I would say, or maybe 47, 46. So bus 2, about 48 miles for every 1 hour. So for this scenario right here, you can see bus number 1 is going faster in 1 hour, 55 miles versus 48 miles. And again, you'd have to show me. All right. I think I have just one more of those for you to do, I guess, and that's it. Or maybe, oh, it looks like I skipped this first one right here, so I'm just going to do this. And again, actually do this one on your own. Sorry, I skipped that. All right, last problem. Is this one right here. So again, they want you to write the equation for both these and then answer the questions. So here we go. It's saying Kaylee is going to the county fair, Riley going to the state fair. Kaylee, her zero term is 4, 0, 4. That's her y-intercept. That's the B number. Her slope, again, which is always rise over run. You could either go up and over. For this one, every time you're going over one ride or over one, you're going up 2. So careful, look at your numbers. You're not going up by ones right here. Over 1 this way is 1, but for each box going up, it's going up by 2. So Kaylee's equation is y equals 2x plus this y-intercept number, 4. And again, this is telling you she's paying $2 per ride. That's what this one's saying. And $4 right here is her base charge, or for this scenario, how much she's paying to get into the fair for this one. So Kaylee's spending $2 per ride, and to get into this county fair cost her $4. That's what I get from this graph. Same thing from the table. For Riley going to the state fair, her y-intercept is 1. That's her base charge. That's her B number. Her slope, or her M, or her common difference, comes from how much these are going up. And again, because my x numbers are just going up by 1, I don't need to worry about finding my slope, which is change in y over change in x, if these were not going up by 1. But again, just going up by 1s, just focus on the y numbers, or these numbers. So that is going up by 3. That is my slope number, my rate of change, my slope, my m, my d. So for Riley, her equation is 3x plus 1. And again, this is her, how much she's paying per ride, $3 per ride. This is her base charge, which again for this problem is how much she's paying to get into the fair. So now I can answer the questions. It says it costs $3 more to get into the county fair than the state fair. County fair is $4. The state fair is $1. That is 3 more. So that is true. It's tricky there. You have to write the equations and then compare those two numbers. Yes, this is 3 more than that. $3 more than Riley's state fair that costs to get the county fair. All right, 5 rides after for each. Kaylee will spend $8 less than Riley. So here we go. Kaylee, for her 5 rides, $14. Riley, for her 5 rides, $16. And you could see that's definitely not $8 less, so that one's false. All right, when Kaylee and Riley gone 3 rides, they spent the same amount. So Kaylee 3 rides, $10. Riley after 3 rides, also $10. So that one is true. And then it costs $4 per ride at the state fair. And again, nope, for the state fair, which is this equation, Riley's equation, it's $3 per ride. Be careful, they're trying to bait you again into thinking that's how much it costs per ride. Nope, this is per ride. That one, that's the base charge, so that one's false. All right, couple more of those. Here we go. So the equations, y-intercept of 6. For this one, every time I'm going over 1, I'm going up 3. That's my slope. So for Kaylee, for this situation, going to the county fair, 3x or $3 per ride plus $6 that you're spending before you even sit on a ride or even look at a ride. That's how much you're spending to get into the place. $6 your base charge. So $3 per ride, $6 entry fee to get into the fair. All right, for the next one, table. Y-intercept is 2. That's her base charge, or her y-intercept, or where her graph would touch the y-axis if it was graphed. This one going up by 4. That's your slope or your rate of change. So for Riley's state fair equation, 4 goes in front of x, $4 per ride, plus 2, the y-intercept number, the base charge, or how much it cost to get into the place. This is entry fee for this problem right here, how much to get into the fair. So here we go. It costs 4 more than to get into the county fair than the state fair. So the county fair costs $6. State fair $2. Yep, that is 4 more. Kaylee and Riley 5 rides. Let's see. Kaylee after 5 rides, $21. Riley after 5 rides, $22. So this one's false. Kaylee and Riley 4 rides, same amount. $18 for Kaylee. For $18 for Riley. That is true. And then this one, $4 per ride at the state fair. For this one, yes, they didn't try to bait you into thinking this was $6 per ride. That is true for this problem. All right, that's one of those. Next 2 I'll have you do on your own. I will help you. This equation, y-intercept of 3. slope of over 1, and according to this table here, or this graph, going up by 3. So that equation for Kaylee for this situation, $3 per ride plus the $3 it costs to get into the fair, or at the 0 term, or after not riding any rides at all, how much you spent. $3 per ride, $3 for this entry fee into the fair. Riley's table has a y-intercept of 6. It has a slope, or m, of 5 for this table, going up by 5. So her equation, 5x plus 6, $5, $6 entry fee. It costs $3 more to get into the county fair than the state fair. So county fair is 3, state fair is 6. For this one, that would be false. It costs $3 more to get into the state fair than the county fair for this one. So that would be false, unless this was state and this was county. All right, next. 4 rides. Kaylee, $15. Riley, 4 rides, $26. Kaylee spent $11 less than Riley, and you could see, yes, if I added 11 to this, it would give me 26. Kaylee spent $11 less than Riley. That would be true for this one. Kaylee and Riley, 3 rides, same amount of money. Kaylee, 3 rides, $12. 3 rides, $21. This one is false for this one. $5 per ride for the state fair. That is true, because again, they're not trying to bait you into thinking $11 per ride. That one would be true. Alright, the next 2 I'd like you to try. I will help you. For those of you who are now transitioning into this being the homework, actually scratch that. Good luck.